to. The whole first page is what we call a work rate problem of some kind. So it's either going to be like 2 or 3 people or maybe objects working together or working against each other to accomplish a task. And then we're going to do some uniform motion problems on the back. So kind of like 2 types that you're going to see in this kind of unit with rational equations. So I'm just going to read this to you really quick. It says, Amy and Sarah have volunteered to contact every member of their club by phone to inform them of an upcoming event. It says Sarah can complete the calls in 10 days if she works by herself. Amy can complete the calls in 8 days if she works by herself. And then if they work together, how long would it take them to complete these calls? Okay, now this is the thing you're not going to see ever in a book or anything like that. I'm just going to let one, because it doesn't say, hey, we're making 500 calls or whatever. So I'm just going to let one represent making all these phone calls. Okay, so we've got these 2 girls. Which one does it say first? It says Sarah can complete the calls in 10 days. So her rate, this is how I would write it. All the calls, which would, I'm just going to use the number 1 to represent that. You could use a variable. You could use a different number. I always just use 1 because it's the smallest thing I can work with. And then she can complete those calls in 10 days. So like 1 set of calls can be completed by her every 10 days. She's not going to repeat this, but just to kind of get it into your mind as a rate. Okay, now the other girl, her name is Amy, and she can complete that same 1 set of calls. It would take her 8 days to do this. And then if they work together, I did not mean to spell SAT, but that's what they have in there. So the same set, that 1 set of calls, and you don't know how long it would take if they helped each other. So that's what we're trying to figure out for this question. So if they're helping each other make these calls, what do you think I would put in between the 1/10 and the 1/8? Addition sign, exactly. Okay, now, I'm going to tell you the easiest way to solve these is just to try and tell me what would be a common denominator between 8, 10, and x. 40x probably. Okay, so top and bottom here, I'm going to go by 4 and an x. Top and bottom here, to get to 40, I'm going to do 5x. And top and bottom here, I have an x, so I would just need the 40. So my goal there, I'm just making 40x my common denominator. You could use 80x. The algebra would be a little bit different maybe as you go through to solve, but we'd still get the same answer. So then, if my denominators all match, that forces our numerators to be equal. So this would just be 4x plus 5x is equal to 40. So you get 9x equals 40, and that's not a nice number. And then we would just divide that. Okay. So many of these problems might have a fraction or a decimal answer, and it's not going to tell you what to round to. So just whatever you're comfortable with. You can see on the screen there, I'm going to say it's actually a repeating decimal, so I can just indicate that. So a little less than 4.5 days if they were working together. You know what? If, like I work at a boutique, we have to like call people and tell them like their coupons are expiring or something like that. Like I do that all the time. So you know how many phone calls? Yeah, you would think, but no. We have to make physical phone calls. It's more likely that you're going to respond to it if somebody actually calls you than if they were to text you or email you. Little marketing thing. Anyway, all right, so now this one's very similar but set up a little different. Okay, it says Eli can paint a room in 3 hours. So I kind of cheated before class and wrote these down. So I said let 1 represent just painting the room. It doesn't tell you like, oh, it's 500 square feet, or it doesn't tell you anything like that. So I'm just going to let 1 represent painting the room. So this says Eli can paint this 1 room in 3 hours. Okay, if his sister Faith helps, it takes them 2 hours and 24 minutes. So his sister Faith is going to help him, but it doesn't tell you her rate for the 1 room. So for Faith, I don't know. This is what we're going to figure out. So my variable is going to be kind of in the middle here. So the 1 room, we don't know her time. Now, for the time together, he's 3 hours, she's together they're 2 hours and 24 minutes. Okay, you can't just write like 2.24, right? How would I convert 2 hours and 24 minutes into hours? Like, what would you do with the 24? Divide by 60. Okay, so let me just see what that is. If I do 24 divided by 60, that's 0.4. So then this would be 2.4. Ooh, yikes. Okay, so I don't really want to deal with the decimal there. So here's what I'm going to do just really quickly underneath that. I'm just going to get rid of the decimal. I'm just going to multiply the top and bottom of that fraction by what to get rid of the decimal? 10. All right, so if you just do this, this would be 10 over 24. That way we don't have to mess around with the decimal. Okay, what would be a common denominator between 3x and 24? 24x, right? Because 3 does go into 24. All right, so just figure out what you're missing. Here, top and bottom, I'd be missing 8x. In the middle, I would just be missing the 24. And on the end, I have the 24, so I'm just missing the x. So if I'm solving this guy, we're going to have 8x plus 24 equals, excuse me, 10x. If you make all the denominators match, that forces the numerators to be equal, and you just work on that. I would subtract 8x there from both sides real quick. So I'd get 24 equals 2x. And so then x is going to be 12 hours. So maybe Faith is like 5 years old and they probably shouldn't make her paint a room. But anyway, that's why it takes so long.
That's a long time.
It's a long time. Okay. Maybe she's a perfectionist or something. Okay. All right. Now, this next question's a little weird. Okay. So this says, think about your bathtub. So it says, if the faucet is running, it takes 10 minutes to completely fill this bathtub up. So if you leave the faucet on, 10 minutes to fill it up. It says it takes 14 minutes to drain. So if the drain was open, to drain the bathtub if it's full. It says if the faucet is running and the drain is open at the same time, could you actually fill up the bathtub? You walked out of the room and you are an idiot. I've done this many times. Okay, don't judge. But like you forgot that you had the drain. You forgot to close the drain. So would this even be possible?
Yes.
Why would it be possible? Like, how do you know? Right, it fills faster than it takes it to drain. Okay, does that make sense? So this is possible. Okay, so to fill the bathtub, so the rate here to fill the one, I'm just letting one represent filling up. It doesn't tell me, here's the volume of the tub or anything like that. So to fill the tub up, it takes 10 minutes. I'm going to leave a little space here. To drain the tub, it takes 14 minutes. I want to know if I could actually fill this bathtub up. So I'm going to find the time it takes to fill up the bathtub. What would you put in between those two fractions? Are they working together? No, right? The drain is pulling water out of the tub. So what would you put between them? Subtraction, yeah, because the drain is going to pull the water out while the faucet's putting the water in. So it's just a little different than those other two. Still a work rate problem, but the two objects here are working against each other. Okay, now, what should we use as a common denominator with 10, 14, and x? And if you can't think of it, you can always take the 10 and 14 and multiply them together. I think they both go into 70 though, yeah. Yes. Let's use 70, just a little bit smaller. If you work with 140x, we'll get the same answer, just a little different algebra. So let me go 7x top and bottom here. This would be 5x top and bottom here. And I already have the x, so I'm just going to make it 70 top and bottom of the last fraction. If those lovely denominators all match, it forces the numerators to be equal, so I'm just going to work with the top. It would be 7x minus 5x equals 70. So this is actually a nice number here. We're going to get 2x equals 70. X would be 35 if you divide that. Since the information about the faucet and the drain were both in minutes, then your answer's in minutes. So it could happen. It would take 35 minutes. Hopefully you don't leave a bathtub unattended that long, because that's not safe. Okay, Now, you should come check. You should come check. Exactly. Okay, now these ones are going to have a couple or not a couple variables, but we're going to have variables in more than one of the fractions, if that makes sense. Okay, so this is working together. Jenny and Mackenzie can landscape a yard in 3 hours. Okay, if Jenny works alone, it takes her 8 hours. This is kind of weird. 8 hours longer than it takes Mackenzie to landscape the same yard. Okay, how long would it take each girl to landscape the yard if they worked alone? Okay, so I'm going to let one just represent landscaping the yard. All right, so they're going to work together here to help each other. So I'm going to put a plus sign in between. And together, all of the tops would be 1, right? They're all working on the same yard, one set of landscaping this yard. It tells you together they can do this in 3 hours. So the 3 hours for the together would go on the bottom there. Okay, now it says if Jenny works alone, it takes her 8 hours longer. X plus 8, there you go. So 8 hours longer. So if we say Mackenzie's X and we would just 8 hours longer, we would just add. Don't multiply. You want to add 8. Bless you. Okay, now this one, I'm not going to lie to you. This one is a little trickier because it's going to turn into a quadratic. So don't forget, you can't just like add 8 to make these match. All right, it has to be with multiplication. All right, so I need each one of these denominators to match. To do that, this first one would need a 3 and an X, top and bottom. The second one would need a 3 and an X plus 8. And the third one has the 3, but it doesn't have the plain X or the X plus 8, either one. So it would need both. All right, now, because we have 1 on the top, this will make these a little bit easier, but I do have to do a little distributive property. So that very first fraction, the top, would just be 3x. The one in the middle, 1 times 3 is just 3, but I got to distribute that to x plus 8. So I'm going to write 3x plus 24. And then on the other side, you do a little distributive property again. 1 times x would just keep it x, but I got to distribute that to the x plus 8. And this is where the quadratic is going to get created, because you're going to get x squared plus 8x. So I have 6x plus 24, x squared plus 8x. Now, I promise if you get a quadratic, it'll be factorable. So what I would do here, I'm going to set this equal to 0, but what I would recommend is keep the squared term positive. Okay, so to do that, I'm going to subtract 6x, and I'm going to subtract 24 just in the same step. So we'd have x squared, let's see, plus 2x minus 24. And then I want us to try and think of, can you think of 2 numbers, when you multiply them you get negative 24, same 2 numbers would add and get 2? 6 positive and 4 is negative. Doesn't matter which one comes first or second. Now my actual answers there, right, would be negative 6 and positive 4. Are we going to use both answers? No, right? We can't have a negative time, so I don't want to use the negative 6. That's not going to be helpful. So the 2 times for the 2 girls here, if it's 4, it would take Mackenzie 4 hours, and it would take Jenny 12 hours if they were working alone. Is anybody having a question? Okay. This one's pretty similar, but just a little bit different wording. Okay, now, this one I'm going to let 1 represent completing this project that I'm about to tell you about. Okay, so it says Grady takes twice as long as Lydia to complete a project. Together they can complete the project in 10 hours. How long would it take each of them individually? So again, I'm just going to put a 1 on top of each of these fractions to represent completing this project. Guys, why is everybody talking? Okay, we're going to work together And I just got to figure out how to write the bottom. It says together they can complete this project in 10 hours. So that can go on the together rate. One whole project every 10 hours. Now, it says Grady takes twice as long as Lydia to complete the project. So how would you write down the bottom of the other two fractions? 2x and x. That's all you have to do. Okay, now, what do we want to use as the common denominator here? 10x, that's what I would do. So top and bottom here by 5, top and bottom here by 10, and top and bottom here by x. Now, this literally becomes, let me grab a different color, you have 5 plus 10 equals x. Literally, like the bottom, it's literally just 5 and 10. And so 15 would be x. Now, x is going to be Lydia's time, so it would take 15 hours. And then if you take, Grady takes twice as long, so you would double that. So then he would be 30 hours to complete the project alone. Is anybody having a question? Okay, now I'm going to skip this one at the top, just because it's really similar to the ones we just did. And so just go ahead and cross that one out. Just skip it, because a couple of these at the bottom take a little bit more time. So just cross that out. It's the same one we just did. It's just a little different question. Okay, but I am going to move into this one. Now, I'm going to write down a formula. You guys probably used a bunch, maybe first semester in Algebra 1, so I know that's super fresh in your mind. See if you guys remember this. So there's a little formula. Some people call this a... Oh, okay, you do know. Okay, so some people call this a dirt formula. It's called distance, rate, time. So it's definitely dirt. Okay, so distance equals rate multiplied by time. Now, we keep doing rational equations, right? So this isn't really something that has a fraction as you're looking at it. So I'm going to transform this just a teeny bit more into what you guys are going to see in an actual problem today. Most of these are going to deal with time. And so if I manipulated this equation, it's still the same equation, but I solved it for the time. If I do that, the time that somebody is working on something or traveling or doing something is equal to their distance divided by the rate. And this is actually what you're going to use to help you do all these problems today. These are called uniform motion problems. So if you have like a boat or a car or a train or something, it's going to be this type of a problem versus what we did on the front. So it's a little different. I'm not going to let one represent anything here. Okay, so this says we have a passenger train. So I'm going to write passenger train. And it's going to travel 392 miles in the same time it takes a freight train. I'm going to write FT for freight train. And that's going to travel 322 miles. The key here says in the same time. All right, so the times for these two trains are going to be the same. Okay, if the passenger train travels 20 miles an hour faster than the freight train, find the speed of each. Okay, now here's how I'm going to kind of set this up. So the times for both of these trains are the same. So what I'm going to substitute in here for that is, instead of time, we're going to set up, bless you, the distance divided by the rate for each of these. So we're just going to grab this information from the problem. So it says the passenger train, the distance is 392. The freight train, the distance is 322. Okay, now it does not tell you the speed for either train, so we're going to find it for both. It says the passenger train, so this one, travels 20 miles an hour faster than the freight train. So here's how I'm going to write this. I'm just going to use R for the rate. Rate is your speed. So let me say that the freight train is R, and then it says the passenger train, they're going farther, so they must be going faster. So whatever that speed is, but 20 miles an hour faster, so I'm just going to write R plus 20. And then completely up to you. If you want to just straight up cross multiply like a proportion, you can do that here. Or if you want to create the same common denominator, it would be the same algebra. This one's missing an R minus 20. This one's missing an R. All right, so my lovely equation that I'm going to solve, we're going to have 392 times R. And then on this side, Don't know what that is off the top of my head, so let me grab my calculator. 322 times 20, so we got 322R plus 6,440. And then once you set these up, like I said, the tricky part is setting the equation up, actually solving it. It's not too bad at all. This ends up being 70 if you subtract that 322R from both sides. So 70R, bless you, 6440. And then what do we got here? The rate here, if I found just R, that's the rate for the freight train. All right, so let me go back and write this in. So the freight train, this guy would be 92 miles per hour. And then the passenger train is going 20 miles an hour faster, so I would just take 92 and add 20 to it. So 112 miles per hour. It's kind of two answers to this question because it's once the speed for both vehicle or both trains. Is anybody having a question? Okay. Now, this is kind of a weird problem. Okay, so it says Luke can row 5 miles per hour in still water. All right, so his rate is 5 miles per hour. So that's his speed. So they're giving me the rate here. Okay, it takes Luke as long, so I know this is kind of a little deceiving. So these are going to be two times that are the same again. Takes as long to row 4 miles upstream as it does to row 16 miles downstream. So if he's rowing 5 miles an hour and those two distances are obviously radically different, that means there's a current that's working either for him or against him. So see if this makes sense. Okay, so I'm going to do up and down, upstream, downstream, right? The times are the same. So distance divided by rate, again, I'm just substituting that in for time, is going to be the same or set equal to each other to help you solve this. Okay, upstream, the distance is 4 miles. Downstream, the distance is 16 miles. So I'm just setting that into the top of each of the fractions. Okay, now, since the distance is radically different, but he's traveling the same speed, right? His speed, just leave a little bit of space, I'm going to put the 5. If he is going only 4 miles, then the current in the water is going to be working against the boat, slowing him down. So I'm going to write 5 minus C because the current is slowing him down. All right, if I'm going 16 miles downstream in that same time, that means that that current is going behind the boat and helping you, speeding you up. So it's increasing your rate, but we just don't know what the speed of the current is. So we don't know exactly what that number would be. Okay, now I know we did some equations last week where we pulled out a -1 and helped match up something. You will not be able to do that on these questions. Like if you factor out a -1, it does not make it match the other side because one of the variables will be positive and one will be negative. You can't get them to match. So to do this one, to create a common denominator, or if you want to straight up just cross multiply, you're going to do it like this side would need a 5 minus C to make a match. This one would need a 5 plus C. So you can't factor out a -1. I just wanted to make a point about that. You're just going to have to create a common denominator, or very similar to last one, you can just cross multiply like a normal proportion if you want to here, because you just have two fractions, excuse me, set equal to each other. Okay, now, I'm going to do a little distributive property here. You're going to have 20 plus 4C equals 16 times 5 is 80 minus 16C. And if you're doing any of these problems and you end up with like a negative answer, you probably just put the minus sign on the wrong fraction. Okay, so you might just switch that up if you get a negative answer as you go through here, but we should be okay for what we have. All right, so I'm just going to do 2 steps in one. I'm going to add 16C to one side to get all my variables on the left in my equation. And I'm going to subtract 20 in the same step. That'll move all the numbers to the other side. So I'm going to get 20C equals 60. And then we're just going to divide by 20. What's the speed of my current? 3. Oh, okay, I about had a heart attack. Okay, I was like, 3. 3 miles per hour. If you want to plug these back in to check to see if the two sides of the equation are equal, you can easily do that. Is anybody having a question? Okay, now I'm not going to lie to you. We have some garbage numbers on this question because they're really big numbers, but it's not hard to solve this. Okay, says the flight across the United States takes longer if you're going east to west than it does west to east. This is kind of the same concept of the current in the water. It says when you're flying west, a headwind, when you hear the word headwind, it comes against the front of the plane, so it would slow you down, decreases the speed. If you're flying east, the tailwind goes across the tail of the plane, so it would increase the speed. The wind would help you. Now, the time for a round trip, we're going to go from Chicago to San Francisco, is 1,850 miles one way. And it says the round trip is 7.75 hours. What does round trip mean to you guys? There and back. Okay, so we're going to go there and back. All right, so I'm going to go from Chicago to San Francisco. Then I'm going to turn around and I'm going to fly back from San Francisco to Chicago. And the total time is going to be basically what I'm going to do here. I'm going to add the two times together, and that's going to be the total time for the trip. All right, I guess I should write that here. So the time to go here plus the time to go here is going to be the 7.75 hours, because round trip means you go there and you go back. Okay, now remember, the time is just the distance divided by the rate from that lovely dirt formula, kind of transforming that a little bit. The distance for both of these is exactly the same. The distance is the same number of miles. It tells you in the problem 1,850. Okay, now what else? Oh, I forgot to keep reading this. It's giving you the general speed of the plane as 480 miles per hour. So we're going to have 480 on the bottom of both of these fractions. Okay, now if I am going west, the wind blows against the plane and slows you down. So I'm going to say for that, from Chicago to San Francisco, 480 minus whatever the speed of the wind is. When you go back, the wind helps you and is going to speed the plane up, and it's going to make that time go a little bit faster. So going back, it'll be almost identical, but you'd have 480 plus the wind. All right, now don't worry about the decimal here, but I'm going to add these two times together to get the total time. So it's a little different than the last two questions, because these are not equal times, because one has the wind working for you, one has the wind working against you. Again, you can't like factor a negative out to make those match, so you're going to get a common denominator between all three of these. All right, so this guy would need 480 plus W. This guy would need 480 minus W. And where you got the 7.75, don't worry about the decimal for the moment. We need both of those. We need 480 plus W, and we need 480 minus W. Okay, I'm gonna try to write small. These are kind of big numbers. So the nice part here, what I'm gonna do, I'm gonna distribute that 1850 to that 480, and it is a huge number, but don't think you're doing something wrong or anything like that. So I'm gonna get, it's 888,000. Now you distribute that, you get plus 480W, and you're gonna distribute that again. I'm adding in between these. You're gonna get that same number, that 888,000, but on this one you get minus the 480W. So those actually cancel. So you're just going to have a number on that left side, which is a huge number. It's 1,776,000. Okay, now on the other side, I'm just going to give you a little recommendation. What I would do, I'm going to multiply this 7.75 by this in a second, but I would just FOIL this first. I'm just going to FOIL this first. Now, I don't know if you guys noticed this. This will actually be a difference of squares because those two factors I have there, they're identical except one is a plus and one is a minus. So the middle term is going to cancel out, and just to save some space, I'm just not going to write it. The only two terms that'll exist are 480 times 480, which is going to be 230,400, and then w times that negative w will be minus w squared. Okay, now I didn't do anything yet with that. I got to do that 7.75 times that, but this is not going to be a situation where we're going to have to factor anything. It is quadratic, but we can just solve this equation using square roots. All right, I'm going to take that 230,400 times 7.75, and it is going to give us a decent number, which is 1,785,600, and then minus 7.75 times the w squared. This is not going to be a situation where I have to factor. I only have just the w squared. We don't have a w there. Now, all I'm doing here, I'm gonna kind of cheat and not write it, but I'm going to subtract these two. If you take that 1,776,000 minus 1,780,85600, subtracting, okay. You get negative 9,600, negative 7.75 w squared. Yeah. Say that one more time. The for here? Because one's a plus, like when you distribute this is a plus 480. Oh, it should have been 1850. What did I do that for? But they still would cancel out. They would still cancel out. I didn't do that. I'm an idiot. Okay, sorry, hang on a second. You guys, this should have been 1850 W. It still cancels. It's my fault. It should have been 1850, but they still cancel. So don't worry about that. I don't know why I wrote the 480. I was just looking at the number, I think. It would be 1850. They still cancel out because you get one plus and one minus. My fault. Everything else looks okay, though. Now, once you're here, the negatives will act. I'm just going to do this on my calculator screen. The negatives are going to cancel out. So I'm going to take that 9,600 divided by 7.75. Now, that's equal to w squared. So this is not a nice number. So I'm going to take the square root of this to get my answer. And we do not want to take the square root and get a negative here because w represents the wind speed. So we can't have a negative answer. So the wind speed here, we're just not going to do plus and minus. And it doesn't tell me what to round to, so I'm just going to go one decimal place here. Let's say about 35.2 miles per hour would be the speed of the wind. Yeah, you get up in the clouds. It's a windy day. Happens. Is anybody having a question?